Hi everyone. Today we are going to continue the big O analysis, but not that just big O and big O, big omega, and big theta. And those notations are very important for the algorithm course. And last class, and we cannot finish everything, but I want to review them to make sure that we are on the same track. Okay, so let's review what is big O. So for the big O, we said we should first have a Fn. So how do we have the Fn? And to have that Fn is usually the Tn. And remember, Tn is is from the process of counting how many primitive steps we have to execute if the input size is n, right? So the input size is n, and then we visit the lines of the algorithm to count for each line of the code how many times we execute each line, and then we add them together, and that is the total cost of this algorithm, and then we have the Tn. Okay, so from the Tn, we want to move on and we want to figure out the upper bound and the lower bound, which is O, big O, and big omega. And after we have the big O and big omega, and then we have a accurate bound, and that is big theta. Okay, so let's assume that we have already got the Tn, and the Tn is now a function or a polynomial of n, and we call that Fn. So we have the Fn, and how do we figure out the big O? The process is, to figure out the big O, we want to have a constant c and a constant n0. And our goal is Fn will be smaller or equal to the constant c multiplied by gn for all the positive values when n is greater than n0. Okay, and if we and the quick rule or the quick process we usually do is, if we have a polynomial of the degree of the k for the given Fn, and then we just grab the highest degree of polynomial, and then we can say, okay, that is big O n powers k. Okay, and let's see this exercise. So if we have Tn is n squared plus n 9n. So we say it is O n squared. Is that true or false? So think about that. Okay, remember this is the rule we just talked about. If we have a polynomial and the highest degree is k, and then we can say that is big O in k. So if we apply this rule here, and you will find, okay, the highest polynomial degree is 2, so O n squared, so it is big O n squared. So this is true. And if you use this quick and easy way to figure out the big O, that is perfectly fine. But now I want to show you how to do that in a hard way. So we are trying to find the upper bound of the Tn, right? So our goal, remember, is to find an upper bound. Okay, and then how do we do that? So Tn is smaller equal to n, let me grab n squared. So n squared, and then plus, nope. Okay, that's annoying. Okay. So it's smaller or equal to 9. Okay. Let me do another way. That is annoying. So this is smaller than n squared plus 9n squared, right? Because we are increasing this one to 9n squared. So let me ask you this. In what condition is n smaller than n squared? So, okay, we have to say we are assuming n is greater than 1, right? Okay, and then if we want to make a even larger boundary, and then we can do smaller or equal to 10 n squared. Okay. Let me do a copy and paste. Okay, good. So now we have the observation that Tn is going to be smaller or equal to 10 n squared for all the values when n is greater than 1, right? So what is c? Oops, lowercase c, please. What is c? The c should be this value. So c is 10. And then what is n0? N0 should be 1. So let's grab the definition here. So there exists a constant c and the n0 such that fn, which is our tn in this case, is always smaller than c, which is 10, and gn, which is n squared, for all the n values when n is greater than n0, and in our case n0 is 1. So let's grab this line and then make the change here. Okay, so there exists a positive constant c. What is c? C is 10. And then n0 is, oops, I want to do, this is 10. And then n0, this is 1 here. So this 10, and what gn will be n squared for all the n when n is greater than 1. Right? So we just plug in 3 components here. We answer the question, what is c? What is n0? And what is the gn, the function of the n we are looking for? And what is that? That is n squared. Right? So eventually we are able to prove that. So Tn is O n squared. Okay, so this is a full proof of a given Tn, and then we are able to prove that the Tn is On squared. Okay, so this is the full proof. And if you know this, and I'm not asking you, if I'm not asking you for a formal proof, and then just apply this trick, and then you will get it right. Okay, so I'm going to delete this process. And let's move on. Uh-oh, I have to change that again. Okay, so how about this part? So we are still doing the same polynomial, but now we are discussing whether it's a big O n cube, true or false. That's weird, right? Because, well, we know it is a O n squared is the upper bound. And then how about O n cube? So the short answer question for this is, remember, O n cube goes even faster, or it goes even steeper than On squared. So if On squared is already an upper bound, and this means On cube, which is even faster, has to be the upper bound too. So again, if if we imagine that, it makes sense. But how do we prove that? So we have to use the same trick again. So we have the Tn, right? So we have the Tn, and then we want to figure out a upper bound. And let me apply the same trick again. So I'm going to grab this, and then n squared, and then let me do a 9n squared. So I'm increasing this 9n to 9 squared, but it is okay because I'm trying to find an upper bound. So it's fine. And then it is smaller or equal to, and oops. Oh, I worked on the wrong place. Here. So this is 10, and then n squared, right? And then remember, it is also for n greater than 1. For n greater than 1. Okay, and then I want to do one more step. Oops. This one more step is, well, since n is greater than 1, so it's guaranteed that n cube is going to be greater than n squared. So I'm selecting that for one upper level, and that is fine because as long as n is a positive value and n is greater than 1, it's guaranteed n cube is greater than n squared. Okay? Okay, so the next part, we want to go back here, and I want to grab this part again. So let me do a paste. And then we have already figured out the C, the N0, and Gn. So let me just do a replace. So there exists a positive constant C, and then C is 10. Okay? And then the N0. N0 is a 1, such as for the Fn, it is smaller than the C. And then Gn will be uh, Gn will be n cubed. And then for all the n values, for n greater than 1, right? So we have plugged in all three components. So we answered the question, what is C, what is n0, and what is the Gn. So after figure out all three of them, and then we can say, okay, so since the Gn is is n cubed, we can say this Tn is O n cubed. Okay, so that's it for this part. Let me continue. Okay, so just now we spent time talking about the big O, and similarly, well, there is also a lower bound, and for the lower bound, that is omega. And the rule for omega is instead of finding a C multiplied by Gn, which is always higher than Fn, now we want to have another C and another Gn, and C multiplied by Gn is always lower than Fn, and this is our goal. And of course, we also need the N0. And after we have the big O n and big omega n, and if those two Gn's are the same, and then this means we have the same Gn, and C1 Gn is smaller or equal to Fn, and the Fn is smaller or equal to C2 Gn. Why? Because, well, we are assuming that we have a Gn and we have the Fn, which is big O Gn. We also can prove that it is big omega Gn. So upper bound, it is Gn. Lower bound, it is also Gn. So we put them together, and then we have the big omega. Or the easy way to say that is if we can prove that Fn is big O Gn at the same time, Fn is also big omega Gn, and then Fn is big theta Gn. Well, and remember for now, when we are discussing the big O and big theta, we are using a smaller or equal to or greater or equal to, right? Okay, and then the next notation I want to remind you is if you change the smaller or equal to or greater or equal to smaller than or greater than, now we have the smaller O and the smaller omega. And in some cases, we will use the small o and small omega instead of big O and big omega. But it's not so common. Okay, so this is a review on how do we do the big O and big omega and big theta. And well, in our homework and then also in the exam, you're going to see this question. Okay, so I'm going to stop here and move on. We will talk about merge sort.